In the name of God. Hello, dear students of grade 7. Welcome back to Thinkable Physics YouTube channel. My name is Masoud. I'm a science teacher. I'm at your service to explain science curriculum, grade 7. So far, we talked about 4 states of matter, and we concentrated especially on solid. Let me jog your memory about the 4 states of matter. We said that matter is classified into 4 states: solid, liquid, gas, and plasma. And we gave an adequate example for either phase. But in previous lesson, we concentrated especially on solid, and we classified solid into 2 categories: into crystalline solid and amorphous solid. So we finished the information about the solid, but in this lesson, before I start our lesson about the liquid, I have a question for you. I want to check your information. Guess the answer. I'm not gonna spoil the answer. I'm not gonna reveal it. Just guess the answer, and after the lesson, after you watch the video, just comment the answer for me. To make sure you understand the subject, right? I give you 2 substances: aluminum ruler versus rubber hose. So which one is crystalline, which one is amorphous, right? And I want you to think about it and guess the answer. I'm not gonna reveal it. I have, let me jog your memory about the array of either type of solid. We said that crystalline solid has what? Crystalline solid has organized pattern. Atoms are organized in order, in a very, let's say, in a very accurate order. Patterns are actually packed orderly beside one another. They sit beside one another. This is about the, for example, crystalline. Yeah. So this is crystalline. This is crystalline structure. So crystalline structure has a regular pattern. Particles or atoms are organized. They sit beside each other. There's a strong attraction between the particles. And one more, let's say, I'm going to draw an array of the amorphous solid. So they are not organized. They distribute randomly among each other. And the force of attraction between the particles, between the neighboring atoms, is not a lot. That's why this is called amorphous. Yeah, amorphous solid. Amorphous solid. Right. So if you actually think about the pattern is randomly distributed. You cannot name a pattern as a geometrical shape, so it's not organized. That's why this is called amorphous solid. This is about the previous lecture. I'm gonna move on to the new subject, which is our new subject is about the liquids, right? It's about the liquids. Let's get back to the text. So right now I'm gonna explain liquids. The second state of matter is called liquid. Let me read the information, and I want you to put your science book in front of yourself. Any important information that I underline it, I want you to highlight it with me. Let's start. So let me read the definition of the liquid. It says liquid is the state of matter that has a definite volume but takes the shape of its container. What does it mean? Liquid is a state that has a definite volume but takes the shape of the container. It means it doesn't have a definite shape. So it has definite volume but doesn't have any definite shape. Let me underline it. This is the actual definition of the actual liquid. Let me do a simple experiment for you for better understanding. So we have two containers, right? Glass of water, and we have a bottle. Both actually containers are different from each other. The shape of this one is completely different from the shape of the other, right? So here in this glass, the water takes the shape of this glass, right? When you pour it to the another container, what do you observe? What do you see? So what's your observation? Does the water take the shape of the second container? Does the water take the shape of the bottle or not? Of course, yes. That's why liquids in general and water particularly, any liquid actually, it's not just about the water. Any liquid does not have a certain shape. Whenever you pour it to another container, it takes the shape of the second container. But what do you say about the volume? What do you say about the volume of the actually liquid? Your book says it has a definite volume. What does it mean? For example, this bottle, it's just a number. I'm not sure whether the volume of this one is 10 milliliter or 20 milliliter. Anyway, I say anything, whatever number. I say the volume of this bottle is 20 milliliter, right? I'm gonna pour water into the container. So I wanna fill the bottle with 30 milliliter. Is it possible? Whenever you pour more water, the water displaces, right? The water flows. So the bottle does not allow the more water to enter the bottle, right? Because the volume of the liquid is constant. You cannot compress the volume of the liquid. That's why the volume is constant. Liquids have definite volume, but actually very varied shape. They have a variable shape, but definite volume. We have one more example. Imagine I leave this glass of water here, for example, in this room for example, for a day. After 24 hours, right? I come back to the room and tell me about the volume of the water. Does the volume increase or decrease? The answer is no. So that's why volume does not change uh, because liquids have a definite volume, but shape changes from uh, container to the other. This is an explanation about actually the liquid, right? The particles in liquid move fast enough to overcome some of the attractions between them. So they have a kind of circulation. They move fast enough. So they have a faster motion than the particles of the solid, right? And the motion overcomes the attraction. It means there's a medium attraction between the particles of the liquid. But if you remember about the solid, we said that they have a strong attraction between two neighboring atoms. But we don't have this case in liquid. There is an attraction, but I cannot say weak attraction. The attraction is medium. It's in between, actually, between the solid and between the gases, right? It says the particles slide. So the kind of the motion is sliding past each other, right? Sliding past each other until the liquid takes the shape of the container. You see, it says takes the shape of the container. It's a repeated information because in the first line it mentions it for us, right? Let me I'm going to number the actual properties of liquid here. How many liquids properties are there here? Tell me. The first one, liquid, is a state matter that has a definite volume. This is the first property. But takes the shape of the container. It's indefinite shape. This is the second one. Takes the shape. Second. The particles in liquid move fast enough. So motion is a little bit fast, right? The particles slide, and the type of motion is sliding past each other. Or we can say circulation. You have circulation, motion in what? In liquids. But we had actually a vibration in solid, if you remember. And we said vibration means moving up and down or back and forth. It's a very actually limited motion, restricted motion. Restricted. It's not freely motion. But liquids have a motion, and particles of liquid or atoms of liquids are faster than the atoms of solid, right? Another title: liquids have unique characteristic. So what's the unique characteristics of liquid? Before I move on to this title, I want you to read the liquid definition and memorize it, right? It says the state of matter that has a definite volume, you see, definite volume, but not a definite shape. So it doesn't have a certain shape, right? What's the second title? What does it talk about? It talks about liquids have unique characters. Let me read the subject and I'll break it down for you. It says, a special property of liquid is surface tension. So this unique property is surface tension. Surface tension is a unique property of liquid. Actually, surface tension is not dedicated just for liquid. We have this phenomena, we have this property in gas as well. So surface tension is common property between liquids and gases. Surface tension is a force that acts on the particles at the surface of the liquid. So this is the definition of surface tension. Is a force. So surface tension is a force. Let me highlight it for you. Is a force that acts on the what? On the particles at the surface of the liquid. So a surface tension is a force that appears at the top layer of the liquid, right? And tries to take up the minimum area. Actually, what do I mean by it takes up actually the minimum area? It means whenever you pour water into the, for example, glass tube, this glass tube, I'm gonna pour some water into the glass tube, and does the water stand straight, or does it make a curved path? So the water inside the glass tube makes a curved path. Actually, makes a curve shaped, right? It makes a curved path, right? So this curved path refers to the surface tension. And by means of this unique property, for example, mosquitoes can move above the surface of water without submerging, right? Without sinking, they can move actually above the surface of water. Surface tension causes some liquids to form spherical drops, right? It says spherical drops. Let me draw the shape of surface tension for you. I'm going to draw it. Be with me. So let's move on to the whiteboard. For example, think about this glass tube that I showed it to you. I'm gonna pour some liquid, any liquid, into the glass tube, and we said that the first surface is not straight. The surface is not flat, right? It's a spherical. So the particles form what? Form an inward actually curve. This is about, for example, water. We have the opposite case in mercury. So mercury differs from the other liquids. The surface of mercury is upside down. But about the mercury, for example, this tube actually contains mercury, right? The surface of the mercury is like this. So the surface is moving outward, not inward. That's why mercury is different from the other liquids. And by the way, this shape, the curved shape in either case, actually is formed by the surface tension. Right. Let's move on to let's get back to the text. So I'm going to read the definition of surface tension. It says, the force that acts on the surface of liquid and tends to minimize the area of the surface. If you take a look at this mosquito, how does mosquito actually move above the surface of water? Why doesn't the mosquito actually submerge? You see? So the path under the feet of the mosquito is very clear. If you take a look at the figure, the particles actually make a spherical shape around the feet of the mosquito. I want to finish the lecture here. I want to leave the viscosity for the next lecture, and I appreciate you for watching this video, and bye-bye.